Alright, we're back. Does anybody remember what the three undefined terms were from geometry? Very important. We talked about it on day one. Remember? Point, line, and plane. What we're going to do now is look at a couple other things, not just a line, that have one dimension, which is length. So, as you can see in the chart, we have a line, segment, and a ray. Well, a line, we talked a little bit about yesterday. It has length, but it goes off forever in two directions. So we label it with the arrows. The arrows mean goes on forever. Let's make this line AB. So we're going to put somewhere on here point A and point B. How do we label points? Capital, not cursive letter. So how would I name this line? I'm going to call it AB, if it'll let me draw, with the line symbol or you could call it line BA. Those are not two different lines. Those are just two different ways to call the same line. So if somebody said, if I asked you to pick out a line in a diagram and someone said, oh, line AB, and someone else said line BA, you're both right. It's just two different names for the same line. So you can actually use any 2 points. I'm having trouble with the pen here. Any 2 points on the line. Now this line only has 2 points labeled, but sometimes you'll have a bunch of points on there. You can name it in any way. Alright? So if I put point C in here, you could actually call it line AC, line CA, line CB, line BC. What you cannot call it is line ACB, like this. Don't do that. When you're naming a line, you use 2 points with the line symbol. When do we use 3 points? Well, that's when you're naming a plane. A lot of people do this when they're starting out. Don't do it. Now, what symbol do we use for line? The symbol has arrows on both ends. What do we need to know about a line? 2 arrows, and it goes forever in both directions. Now here's something else you've also seen similar to a line. It's called a line segment, but a line segment can have several points on it as well, some labeled. We're going to label 2. We're going to call it A and B. Now notice how there's no arrows. These are endpoints. So it has a start, has a finish. I could measure the length of segment AB. So how are we going to write AB? Well, it's the same kind of thing. You use 2 points, but you can't just pick any 2 points to name a segment. You have to pick the 2 endpoints, and you put this symbol. Just like with the line, the order doesn't matter. So this big line segment here is line AB, line segment AB or line segment BA. It's the same line segment. Both of them are correct. The order of the letters is not important, just like with the line. The thing that's different from here in the line is that there are no arrows. So it has a starting point and an ending point. and it contains all points in between. But here's why, that's weird. Here's why we need to be sure that we use the two endpoints for the line. Suppose I put point C in the middle like I did in, well, not in the middle I should say, but in between A and B, like I did in the previous example. When we're talking about a line, we go on forever. So if I say line AC, I'm going forever through A and C. So it's going to be this line going on forever. So line AC is going to be the same line as line AB, the line that goes forever through A and B. In that case, it doesn't matter which 2 points you pick on the line, and it doesn't matter what order. Whatever 2 points you pick on a line, you can name them, and it's the same line. AC, BC, AB, BA. Those are all the same line. On the segment, you have to pick the 2 endpoints, otherwise you're talking about a different segment. So I'm going to trace for you if you watch the cursor. Here's segment AB, from here to here. Go in reverse. Segment BA, from here to here. Do you see how I'm tracing the same segment, the whole thing? You know, you start at your house, you walk to your friend's house. Now you're at your friend's house, you walk back to your house. You're walking the same path. It doesn't matter which house you start at. It's the same distance, the same length. But if there's a stop sign on the way to your friend's house from your house and you stop there, look, this is segment AC, shorter than AB. So the 2 letters, the 2 points that you use, the 2 letters matter. You have to use the endpoints. So here's AB or BA, same segment, but that's not the same as line segment AC, which is just this shorter one here. Could I also call this segment line segment CA? Yes. What about CB? That's this one, or BC. Okay. Now array is kind of a compromise between a line and a segment. It has one endpoint and then it goes off forever in one direction. So here is, let's put point A here, and let's put point B here. For this ray, put 1 arrow. Now, this is ray AB. So array, you're going to go like this. It starts at point A and goes, and it goes forever through point B. So look at this notation here. When I write when I write ray AB with the symbol like this, do you see how the A is closer to the endpoint here on the symbol and the B is by the arrow? So I start at A and go through B. It doesn't matter what direction the ray is actually facing here on the paper. This ray here is ray AB because it starts at A and goes forever through B, and then there's the arrow. Okay? So if it looked like this, what ray is that? Take a minute right here on your notes to write down what ray this is. I will wait a second for you. You can pause if you want. So this is going to be ray BA. It doesn't matter that A is on the left on the picture. Which one is the endpoint? B. So how do we write this when we're naming it? You write the endpoint down first on the left, even though the ray is pointing to the, pointing right to left. So this is ray BA. Endpoint forever through A. There's your arrow. When you write, you're never going to write like this. This is not how we write rays. The symbol for the ray is always an arrow pointing to the right. This first letter is the point that's the end point, and the other one goes through it. So you can look at our picture. AB, which is this one, this is AB, the top one, bottom one is BA. AB is not the same as B. Alright? An array has what? A starting point, and goes forever in one direction. Okay, so here's two postulates that are going to help out with the next information I have to give you. Through any 2 points, there's exactly one line. So here's 2 points. Do you notice how the only line I can draw that's going to hit both points is this line right here going on forever? Not this line or this line. There's many points that can hit just one of them. But if I want to hit both points, I have just one line, right? Similarly, if I have 3 points that are not on the same line, like these 3 points, can't draw one line that'll hit all 3 of them, right? Then there's only one plane. Well, what flat surface are these 3 points all sitting on? They're sitting on your paper, right? There isn't one floating up above the paper towards you. You only need one flat surface, your paper, to get all 3 of those, right? So what I'm going to do here is reveal this chart. In the interest of time, I want you to pause the video and fill out all those pictures, then unpause, and we'll explain what's going on. Okay, go ahead and pause and draw all those. Okay, we only have a couple minutes left on this video, so I have to make sure that I can explain what's going on. Here's our first term, collinear points. That means points on the same line. Now look at our examples here. We already said in the above postulate that any 2 points are always collinear, right? But here's an example of 3 points that are collinear. I can draw one line that hits A, B, and C. So I would say points A, B, and C are collinear. Notice this example. In this example, point D, E, and F, those points are all collinear as well. There isn't a line right now that's drawn that's hitting all 3, but could you draw a line that hits all 3 points? Yes, so they're collinear. Here's something that's a non-example. Points G, I, and H, those are not collinear because I couldn't draw just one line that hits all 3. So, look, collinear points on the same line. So coplanar points are points that are on the same plane. So again, just like we said in the above postulate 2, here's 3 points. Those are always coplanar. In this diagram, there's a line that's punching through the plane. And where's the line hitting the plane? At point A. But points A, B, and C are all on the same plane. Now if you look at this example, points A, B, and C are on the same plane, this flat surface like a piece of paper. But look at the line that goes through the plane. Point D is actually below the plane. So if you hold up your sheet of paper and you have an A, B, and C on it, now picture point D below that piece of paper. What points in this example are not coplanar? A, B, C, and D are not coplanar, but A, B, and C are coplanar. So in order to give you an example of points that are not collinear, I need 3 points. And in order to give you an example of points that are not coplanar, I need 4 points. Lastly, we have something called coplanar lines. That's lines that are on the same plane. Well, here's an example. These 2 lines are on the same sheet of paper. But in order to get 2 lines that are not on the same plane, look here. You need to see this line is on one plane facing you, and this line is on the side. So we'll discuss this further later.